So hi students, welcome back. So last class we were discussing about elements, symbols, valencies, radicals. So today we are going to discuss more about radicals and valencies also. So class we have discussed about ferrous and ferric. I think we have discussed about that. So today we are going to discuss about the various type of radicals like your monovalent radicals, right? Monovalent radical. Okay, so what is the meaning of monovalent? Mono means single, so that means the radical which have either +1 or -1 charge is called monovalent radical. These are the following examples. These are the examples of monovalent positive radicals and monovalent negative radicals. Hope you can see the picture I have pasted here. Radicals, okay, divalent radicals. So di means 2, so the charge will be either +2 or -2. These are the examples of divalent radicals, positive, electropositive and electronegative. Third one is your trivalent radical. Okay, trivalent radical, that is the charge will be either +3 or -3. This particular box contains the trivalent electropositive radical, and this particular box contains the trivalent electronegative radical. So tri means 3. So next tetravalent. Okay, next tetravalent radicals. So tetravalent radicals are, that means +4 or -4. The charge will be +4 or -4. So this is what the type of radicals are. And now let me tell you just one thing before I am going to the next part. There are two types of valencies in generally. Two types of valencies for some elements. Okay, some elements, basically the D group or D block elements, they have lower valency and higher valency. Okay, they have lower valency and higher valency. So for lower valency the suffix will be OUS, and for the higher valency the suffix will be IC. Let's say for iron Fe2 plus and Fe3 plus, you see this is divalent electropositive radical and this is trivalent electropositive radical, but the elements remain same. This is of iron, so iron here is showing two valencies, that is called variable valency. And you see this has 2 positive charge and this has 3 positive charge, that means valency is higher in this case. So for this we'll write ferric, Ferric, and for this we'll write ferrous, Ferrous. Okay, so similarly examples are given here for the higher valency and lower valency. This is cuprous, argentus, this all are of lower valency. And you see here it is like Fe3 plus ferric, here it will be cupric, like. So these are called higher valency and lower valency, and how we are going to use in writing the molecular formula we'll see. Okay, so now next move on to the next part, that is how to write a molecular formula. Okay, how to write a molecular formula. Okay, this is very simple actually, molecular formula. For that you need to understand about this radical, that means it you have to memorize actually. And how will you memorize? You will revise again and again. There is a simple fundamental trick that is called combine the positive radicals with the negative one. That's a very simple thing. Positive radicals with the negative ones. Okay, with the negative radicals. So if you know how to do this, then writing chemical formula will be same for you. Okay, so let's start with a very simple example, that is called sodium chloride, right? Sodium chloride. Remember one thing, here we are going to write the radicals only. Okay, now before writing this radical of means the electronegative radical, let me tell you what is the significance of this term IDE. So IDE represents only non-metal, only non-metal present along with the cation, okay, present along with the cation. So this is the cation here. So sodium means Na1 plus, you can see in the box it is there, Na1 plus, this is sodium 0.7. So Na1 plus, and what is the formula of chloride ion, that is chloride ion is Cl1 minus, okay. So the next step will be, I am telling you the proper process, but after practicing one by one you can remove from some processes, some steps actually, not processes, some steps actually. So now let me remove the charges and let me write Na1 and here Cl1, okay. Now take this superscript into the subscript of chlorine and take this superscript into the subscript of sodium, so it will become Na1 and Cl1. Now the gap between them is little lesser, so finally we are going to write NaCl, okay, we are going to write NaCl because 1 and 1, these two subscripts are same and their HCF will be 1 again. So when we divide this 1 by 1, answer will be 1, and when we divide this chlorine, I mean subscript of this chlorine 1 by 1, the answer will also be 1. Hence the molecular formula will be NaCl, right. So now let's move on to the next molecular formula, that is called magnesium nitride. देखो it's IDE means nitride means it is nitrogen, so N3 minus, this is magnesium means magnesium Mg2 plus. Now simply the first step will be Mg2 and N3, this will come here, this will go there, so it will become Mg3N2, and you see this is 3 and this is 2, so there is no common factor here, so we cannot divide it, okay. So the molecular formula will be simply like this, okay. Next, if I write potassium chloride or fluoride, whatever you write, so this will be K1 plus Cl1 minus, then I can write K1 Cl1, this one will come here, this one will go there, so it will be K1 Cl1 or simply KCl. So this is the molecular formula of potassium chloride. Now next take the example of a good thing that you should know it, right, you must know it. Let's say here I am writing potassium chloride and here I am writing potassium chlorate, okay, potassium chlorate. Can you tell me the difference here? Yes, the difference is it is IT and it is ATE, okay. Previously we have learned about IDE, right. So in this case the cations will remain same, like K1 plus, here also K1 plus, but whatever the anions, listen, when it is chloride means definitely it is chlorine, and T means presence of oxygen, right, presence of oxygen. Let me write chloride ion, let me go to the box below here, or to find out what is the chloride ion, right, chloride. Why I am finding it? Because it will be easy for you to understand how to find out and how to write the molecular formula, right. So chloride is ClO2 minus, right, ClO2 minus, and chlorate is ClO3 minus, right. Minus means 1 minus, okay, minus mean 1 minus, here also 1 minus. You see the difference here, this is chlorine and this is also chlorine, but the number of oxygen present here is more and the number of oxygen present here is less. As I told, T means oxygen. So when you find less number of oxygen along with a non-metal in anion or in the anionic part, we'll use the suffix it, and if you find the non-metal along with the oxygen, that will be more number of oxygen as compared to this, we'll write ATE, okay. So this is simply potassium chloride and this is potassium chlorate. Now let's transcript this, the Cl, or transpose this, we can say O2 1, this one will go here, this will go there. Now K1 HClO2 is a single entity. It will put bracket and we put 1 here. So it will become KClO2. So this is potassium chloride. Similarly, here this is K1ClO3 1. Again it will come here. It will go there. So it will become K1ClO3 in bracket. Sorry 1. So it will become KClO3. Okay, KClO3. Understood? So now let me write one more thing. Suppose sodium nitrate or nitrite and sodium nitrate. Okay, sodium nitrate and sodium nitrate. You see, this is It means less number of oxygen along with nitrogen, and this is At means more number of oxygen along with nitrogen. So for sodium we can write Na1 plus, and for nitrite we can write NO2 1 minus. Okay, so similarly sodium it will be Na1 plus and this will be NO3 1 minus, right? So next step will be Na1 NO2 1, and this will come here, this will go there, so it will be Na1 NO2 in bracket 1, that will be NaNO2 NaNO2. Similarly for sodium it will be Na1 NO3 1, this will come here, this will go there, then it will become Na1 NO3 in bracket 1, or it is NaNO3, it is NaNO3. Okay, so hope you understood the concept of IDE and ITE and ATE. Now one more concept is left, that is called hypo-ITE and per-ATE. Okay, hypo-ITE and per-ATE. Students, please try to understand. This is not a difficult thing to understand, so try to understand the thing. If you have any doubts, you can post your doubt in the comment section. Otherwise you can mail me in my mail ID, that is called saranoorag@gmail.com, right? And also I am requesting you to find any cons. If you find any cons there in my teaching, please let me know. I'll try to rectify it. Okay, so now let's understand about hypo ITE and per ATE. Acha. To understand this, let me write the radicals of chloride, that will be easier to understand. So ClO2 1 minus, ClO3 1 minus. I think we have studied these two just before. Now let me write ClO1 minus and ClO4 1 minus. You see, instead of this, these are the lesser number of oxygen and this is more number of oxygen, right? So when it is lesser number of oxygen, the term hypo-ITE will be used. If it is more, then per-ATE will be used. Let's say sodium hypochlorite. Okay, hypo, sodium is what? Na1 plus, then hypochlorite, this is chlorite. Okay, hypo, when it is hypochlorite, this is simply ClO1 minus, ClO1 minus. So now it will become Na1 ClO1. So this one will come here and this will go there. So it is Na1 and ClO1. Okay, and at the final it will be NaClO. Similarly, if I can write for sodium perchlorate, then for sodium we will write Na1 plus, and for perchlorate we will be writing ClO4 1 minus. So now it will be Na1 and ClO4 1. This one will come here, this will go there. So that will become ClO4 1 and it is NaClO4. So this is sodium perchlorate and this is sodium hypochlorite. Okay, sodium hypochlorite. chloride. Hope you understood. Please try to understand this. These are very important actually. If you are not going to understand this, it will be a difficult task for you to write the molecular formula. Now we are going to discuss few molecular formulas, then we are going to study about how to find out molecular mass or molecular weight. To understand that, we have to understand about a term that is called relative atomic and molecular mass. I'll teach you in a very simple manner what it is necessary for us. We'll be doing that, right? So now let me write few molecular formula like calcium carbonate. Okay, calcium carbonate. Okay, calcium carbonate. So calcium is Ca2 plus and carbonate is CO3 2 minus. So Ca2 CO3 2, this 2 will come here, this 2 will go there. So Ca2 CO3 also 2. You see both 2 and 2 are there, their SCF is also 2. So if I divide it by 2, then it will become CaCO3, right? CaCO3. So let's say sodium zincate. Sodium zincate. Okay, sodium zincate. So sodium is Na1 plus, zincate is ZnO2 2 minus. So it will become Na1 ZnO2 2. This 2 will come here, this will go there. So it will become Na2 ZnO2. So this is what sodium zincate is. Okay, thank you students. We'll be discussing about the next part, that is the how to find out molecular mass or molecular weight. To understand this, let me tell you what is the relative molecular mass, or here I am writing atomic, relative atomic or molecular mass. देखो, relative means what? Relative means when you are comparing any known quantity with unknown quantity, or any unknown quantity with known quantity, means basically you are comparing when the term relative comes, right? So scientists, what they used to do when scientists or any means who are chemists, actually what they used to do is, if they want to measure the mass of any atom, they used to compare with 1/12th mass of carbon C12 isotope, right? Carbon C12 isotope. Again, why carbon C12 isotope? Because this is cheap and it is in abundance also. So that's why scientists are using this thing. So let me just give you a simple example. Okay, suppose this is you know what is this. Okay, so suppose let me put an elephant here, right? Let me put an elephant here. Okay, elephant. If I want to measure the weight of the elephant, then I have to put some kind of weight over here, right? And let's say this is 100 kilos. Okay, 100 kilo. That means I can say the mass of the elephant is how much? 100 kg. Okay, the mass of the elephant is how much? 100 kg. Similarly, if we want to find the mass of any atom, let's say oxygen atom, so how many this 1/12 mass of carbon C12 isotope required is 16. That means 16 times 1/12 mass of carbon C12, right? 1/12 mass of carbon C12. Okay, so this total term is relative, right? The total term is relative because it is comparing with the known quantity, that is called 1/12 mass of carbon C12, right? And this known quantity is known as AMU. Okay, this known quantity is known as AMU. So if I'll ask you what is the mass of, or what is the relative atomic mass of oxygen, you will simply say 16 AMU, right? 16 AMU. Suppose what is the relative atomic mass of sodium, you will say 23 AMU. Suppose you are saying the relative molecular mass of nitrogen, that will be 14 AMU, right? The 14 AMU. Clear? So this is what the relative atomic and molecular mass. I know in the book many things are given, but I am not saying those things because it is not necessary. At the end we have to find out we need to know how to calculate the molecular mass, how to calculate the mass percent, and so on things, right? Let me tell you one thing. The AMU is the mass of one proton, basically, right? Mass of one proton. So whenever I write, suppose let's say 98 AMU, 98 AMU, that means anything. Let's say this is A. The mass of A is 19 AMU. That means A is 98 times heavier than 1 by 12th mass of carbon C12. Okay, then 12th mass of carbon C12. So this is very basic. Try to understand when you are using AMU means you are finding out the relative molecular or atomic mass. Let's say for H2SO4, so it will be 98 AMU. AMU means relative either atomic mass or molecular mass, or you can simply write U for this also. That is called unified unit. Okay, unified unit. Hope you understood this. Now let's write how to find out the molecular mass of the substances. For that you need to know the masses of at least 1 to 20 element, or try to find out the masses if the information is given in the question. Okay, so let's write for magnesium chloride. Okay, so how to find out? This is basically the simple addition only. So the mass of magnesium is 24 plus how many chlorines are there? 2. So 2 into mass of 1 chlorine, that is 35.5. So it will become 24 plus 2 into 35.5 means 35, 35, 70, 71. Okay, so equal to how much? 5, 9. So 95 AMU. Okay, 95 AMU. Let's say NaNO3, this is what? Sodium nitrate. So sodium is how much? 23, because 1 is there. This is 14 plus 3 into 16. So this will be 23 plus 14 plus 48. Okay, so it is 3, 4, 7, 8, 15. 4, 1, 5, 2, 7, 1, 8. So 85 AMU, right? 85 AMU. So this is how you can find out the molecular formula of a substance given to you. Let's say H2O. H2 is how much? 2 into 1 plus 16, that is 18 AMU. Let's say suppose calcium carbonate, okay, CaCO3. So it is 40 plus 12 plus 3 into 16 equal to 40 plus 12 plus 48, that is 100 AMU. Okay, 100 AMU. Understood? Better to write mass of the atom. Mass of the atom divided by molecular mass. Divided by molecular mass. So this is how you can find mass percentage of any element in a given compound. Let's say CaCO3. So first step is to find the molecular mass. Molecular mass is equal to how much? 40 plus 12 plus 3 into 16. So it is 40 plus 12 plus 48. So it is 100. So 100 AMU. Now let's find out mass percentage of calcium, carbon and oxygen present in it. So I can write mass percentage of calcium is equal to how much? What is the mass of calcium? 40. So 40 divided by 100 into 100. This is cancelled out. The answer is 40%, right? Similarly, mass percentage of carbon. The mass of carbon is 12. 12 divided by 100 into 100, 100 cancel. So it becomes 12%, right? Similarly, mass of oxygen, that is oxygen how much? 16, and how many oxygens are there? 3 oxygens are there. So 3 into 16, that is 48, divided by 100 into 100. This is cancelled out. It is called 48%. Okay, it is called 48%, or it is 48%. So how do you know the answer is correct? When you add this, the total percentage should be 100. So then you can see this is how you can find out the mass percentage of an element. Okay, mass percentage of an element present in a given compound. Understood? So now let's move on to next part, that is called empirical formula. Empirical formula. Okay, empirical formula. So again, this is very important thing. So empirical formula represent the simplest form of a molecular formula. Okay, of a molecular formula. Clear? Simplest form of a molecular formula. That means, let's say C6H12. Okay, C6H2. You see, this is a molecule, right? This is a molecule, and these are the subscripts, right? These are the subscripts. Okay, so first step is to find out the HCF of the subscripts. HCF of the subscripts. Then divide these subscripts by the HCF. Okay, by the HCF. Okay, so these two steps are to find out the empirical formula of a substance. Now let us find out the empirical formula of C6H12O6. You see what will be the HCF here? 6. So I can divide this 6, divide 6, divide 6, so it will become CH2O, right? CH2O. Okay, CH2O. Let me write the empirical formula of few elements, few compound, like suppose NH3. So you see, for nitrogen the coefficient is 1, and for hydrogen the coefficient is 3, but there is no common factor, right? Or there won't be any HCF, right? Or if it will be, then it is 1, right? Because we know the HCF or factor of every number is 1, right? Every number is 1, so we can say the HCF here is 1, and while dividing we'll get NH3 again. So that means this will be the empirical formula of ammonia. Empirical formula of ammonia, right? Empirical formula of ammonia. Okay, clear? Next one, let me write CH3COOH. In this case, you see, these things looks that they don't have any common factor except 1, but no, let us arrange it first. So C2H4O2. So now you see the HCF will be 2, right? The HCF will be 2. So what will be the answer here? So C1H2O1. That means CH2O. So this is the empirical formula of glucose. Okay, empirical formula of glucose. Okay, empirical formula of glucose. Understood? So this is for today. Next class we are going to discuss about the chemical equations, word equations, how to balance the chemical equations, and I'll teach you not only hit and trial method, but I'll teach you also algebraic method, and if it is possible, then few equations of partial equation method. Okay, thank you so much. Hope you like the video, and please like, share and subscribe, as I am new to this, so maybe some cons are there, so ignore it and try to understand the points that I am discussing. Thank you so much. We'll see you in next video.